Okay, I think we're back. Welcome to day 4 of software sessions. Continuing this sort of C and C++ tutorial. I'll mention this throughout, but I'll share it now and I'll make sure I type it in the chat too. If people are finding this useful and there's topics they'd like me to revisit in more detail, go slower, or new topics to discuss, feel free to leave a comment about that or leave something in the messages. I'm looking at next week. Probably can't do every day next week, but if there's 2 or 3 days that people are interested or something, and there's interest, I'll continue doing it. If not, we'll probably just leave this tutorial at this, and I'll probably go down to a lower cadence. But let me know what you think. I've had some fun doing this, but we'll go from there. I see we got a few people joining the stream already, so I'm going to leave that comment. So cool. Let's get started here. I'm going to do the usual plug. So if you are new to this video or new to this series, check out the description. It has links to the other videos. This is also part of a playlist that you can watch the other videos if you have like 5 hours of free time and you want to check that out. Otherwise, all the content is hosted here. It's been updated for today. So this is we're going to be looking at the networking folder, and there's actually 2 projects we'll be messing with today. So I'll get Visual Studio starting because it takes a second to start those. There we go. And while that pops up, the other thing, of course, is the actual content for this is on my website, Maloozy Labs, 08malooz.com. You can check it out under day 4, and has some good books that I recommend, as well as a link to the GitHub page, as well as a contact page to reach me directly in case I don't respond to something from the videos. Although I will try and watch the videos and see if there's any comments left behind. So anyway, that's the logistics. Let's get started here. I'm gonna need to actually open these projects because they are in a different location. I had to move them. So I put them all in a folder called networking so that it works out a little bit nicer for Git. So we'll start up one called server. Then I'm going to open one here for client. I'll cheat my way over there. There we go. So these are 2 just base projects. I don't foresee this being a big C versus C++ sort of discussion, sort of like yesterday. This is going to be pretty cut and dry tutorial on getting networking going. This is something that you're probably going to come across in most applications that you do if you're targeting multiple computers in any way, a distributed system, video games, anything like that. So this is something that is good to keep fresh and something that you're probably going to want to do fairly often. So it's good knowledge to have. So we'll start on the client side. So I'm going to start my client application here. The first thing you have to do is we have to include basically a networking library that gives us those abilities to actually reach into our operating system and send packets. So on Windows, that's WinSock. So include WinSock. You'll see WinSock 2, and that's the one I'm going to use. There's some slight differences between the 2. But yeah, I'll do WinSock 2. So the next thing is that we need to set up WinSock and initialize it. So for that, there is this special weird class that you need called WSA data. There we go. And we're going to need to have an instance of that existing. The next thing we need to do is we actually need to call startup on here. And WinSock is one of those things that you always want to check to see if you have an error or an unexpected return. So we're going to do that as well. So after I start up WSA, I'm going to check here and do a WSA startup. There we go. And then it requests a version and a pointer to the WSA object. And it wants it as a word. So there's actually a function called make word There we go. And it basically, it's a macro. There's a lot of macros in WinSock. And basically, it's going to take 2.2 there. That creates the version that we want to use. And then we'll need to pass the object, the WSA object. And then we just need to make sure that this equals 0. If it doesn't equal 0, we need to handle the error. So to get that, we'll WSA get last error. There we go. So that'll get us the error, and then we can print out there we go. Might want to say give it as much information as possible. And then one of the things I like to do is I also like to return the error, just because sometimes I'm calling this this process from another application or something, and having that return value is good. So this would be a really, really super simple program. And you know, if I hit here, I might also want to say that we initialize. So I'm going to give this guy a nice test. Oh, we had some build errors. What are the build errors? 2 unresolved. This is a lowercase. Nope. Let's try just regular WinSock. See if it likes it. Nope. There's always something. So it's not liking those 2. Oh, I know. We actually need to load the library as well. And that requires a pragma. So this is a common preprocessor command to do stuff. And basically, we need to load a library with this. So I bet you it will run now. There we go. Yep. And of course, my computer's antivirus saw that as a potential threat. Yeah, because we're calling into the networking stack. But there we go. So we successfully initialized WinSock on the computer, and that's pretty good. There's a few gotchas, like I said, in this. I'm not sure I need the there's a red squiggly, so you don't need the pragmas don't need to be terminated with a semicolon. You can leave a semicolon anywhere, but it was just giving me the squiggly because of that. But yeah, so there we go. We've got now WinSock initialized on our computer. Now we probably want to do something useful with this. So we probably want to set up a socket of sorts on our computer. So what is a socket and what is socket programming? Sockets are a way that we can send and receive data on a given port on a network. In this case, you know, we'll want to open up like a network socket to talk to like the internet or something like that and load a web page. So that might be socket 80. We might create our own socket numbers, you know, just to make life fun and exciting and not interrupt with other system functions. So commonly, you know, throughout work or throughout, you know, personal projects, I'll pick weird socket numbers, hopefully not conflicting with anyone else. If a socket is, you know, a port is already in use, it will sort of blow up on you, that sort of thing. So, so let's go and let's start creating this function in terms of something that will be helpful for us. So we're going to need to create a socket. So create our socket. Let's go call it sock. And then we're going to need some structures. Remember we talked about structures yesterday as a way to logically group some data. Because WinSock is a C library, we can use it in both C and C++ applications. They use structs a lot. So I'm going to go through here and I'm going to set up a, I believe it's called sock adder underscore in. And this will be our server that we'll want to talk to. Cool, it recognized that. We'll set that up. And then we're probably going to need to be able to send data. If you recall, we've set up buffers before, dynamic memory buffers and stuff. In this case, I'm going to just make a 1024 1024 byte buffer, not terabyte buffer. That'd be huge. And we'll just go from there. And I'm just going to statically declare it for now. You may choose to dynamically declare this depending on what packets are sent, or you might choose to resize it. You'll see that there's some control later where you don't have to do it that way. So I'm also declaring it as a buffer because I'm declaring it as a character array because I maybe want to access this on an individual byte level, and bytes on this particular computer are going to be character arrays. Oh, I'm going to switch over to 64-bit too. One thing I am going to do though is I'm going to make a I'm going to rename that too to make it all caps. If you recall, yesterday I talked about the use of pound defines versus constant integers. I could do a constant integer as well, just look it up from a memory location. But here it'll do it in the preprocessor, and for what we're doing today, that should be fine. So we've initialized everything. We probably will need another character buffer for our reply. So that'll be good, and I'll rename this send buffer and reply buffer. Cool. And then we'll need, we can leave our int error here. We're going to probably end up checking it a lot, but that's fine. We will need a receive size to know how much data we got back. Receive size. There we go. Cool. So those are all good things that, memory things to create. Sometimes I put them at the very top of the function. If you feel like you want to group everything together, that's where I usually put them as like the first thing that happens. But you can put them anywhere or as you need them. So the next thing we need to do is we need to create a socket. Again, because the nature of WinSock and things can go wrong very, very easily. I'm going to do this inside of a an if statement. I'm also going to turn off my video here as well so you guys can see the screen completely. So here we go. We're going to say sock equals socket, and then we're going to say af underscore net. inet, sorry, my bad. So that's saying that we're sending a internet socket. We need to tell it its type. So we want to give usually sock underscore, and we have datagram, raw, stream, whatever. In this case, I like stream because I'm going to create a TCP socket, so a stream will be good for that, and we'll go from there, sort of thing. And then the last argument here of this is going to be the protocol, and I believe for the protocol, there is a IP proto. There we go. And there should be TCP. There we go. And we will check to make sure that that socket is not invalid. So invalid socket. Invalid socket's another one of those lovely defined types for us. So like I said, there's a lot of pound defines and macros in this. We can, of course, go and find out what all these values are. So IP proto 6, it's an enum. So you can see like IP proto 0 is going to be one thing. TCP is 6. UDP is 17. You know, they're all basically different values. So F12 is the way that you can sort of jump to those. You can also see what the valid sockets are by jumping around as well, what an invalid socket looks like and stuff like that. So should we have this problem, I'm going to want to say creating a socket failed. And give us an error code. So, and I'll print down here. Socket created. Now, there is something that you want to do before I test this and show this. I do want to close the socket at the end. So there is a close socket function. And close socket just takes our socket. Socket closed. There we go. We go to run this. Let's see if we have any issues. Socket created, socket closed, no issues. The only issue for me was that I did not put the /ns on the end of this. So cool, we've now created a socket. That's nifty. This is really sort of the hard part. The next step is really just to have it go look at something. That's the next part. So let's make some space here, and I'll scroll down so you can see this. So we're going to need to set up what we called the server. So server, there we go. This this struct has a few different things. The first one is the address that it needs to get. And there's a function that we're going to call called inet_adder. So internet address. And this is where you can convert a string to a internet address. So it does all that parsing for you. So I'm going to do 127.0.0.1, which is just sort of the local host of the computer. I then need to give it a family. I messed up something here. I probably can't set that directly. Can I? Yes. Does that work? That worked. Okay. So we need to define it. So, yeah. That's a macro, if I'm not mistaken, a pound define there, that will expand the value to correctly. So that's all I'm doing. And the mouse over in Visual Studio is fantastic for that sort of thing. I need to give it a family, let it know what it is. We told it when we created our socket here that we made an internet socket, so we'll tell it the same thing. We're using the inner tubes. And then we need to give it a port. So, and this one, you know, we get to make up or use. We require a small function, htons, and this converts our port to what will be usable by our convention here. I'm going to pick a port, I don't know, 10-240. Make it a big port off there in the real world. So cool. We have now set that up, and the next thing that we would need to do is we would need to connect to this server somewhere. So before we do that, we probably should go set up the server. So the good news is that we can reuse some of this stuff. So I'm going to copy all of this to start. We will just close out anything we don't need. So I'm switching to my server project, because ultimately we're going to need both of these programs to run at the same time. There we go. And actually, I'm going to need a couple more things from this. I'm also going to need that, where we set up WinSock. And what I'm going to do for those folks following along is I'm going to hop on Git really quick. And add client. Nope. Might just be that one that's dirty. Yeah. Okay. That way, if you're following along, you can use this to catch up to where we're at. So if you pull that down, you should be up to date. Cool, so now I'm going to work on the server here. I probably also need that pound define for the message size as well. There we go. So looking at the server, I'm probably going to need 2 sockets. I'm going to need one for listening and one for actually sending data. So I'll call one listen and one reply. Now we'll need to change a few things down below. Receive size I'll still probably need. And I'll probably have a server and a client, because I'll need to know some information about the client coming in here. So the good news is that our initialization is all good. But first we're going to need to create our listening socket. That's going to be the first step. So set up listen. And that's fine if we set up listening to do the same thing here. There we go. I'll just put that in the text here as well, just to help us as we go to debug. But now we need to prepare on this computer, what do we want to listen for? So the address we're going to change, and this is sort of quick and dirty because, yeah, for reasons, we're not too worried about what address is connecting to us, and we're not listening on this particular address. We're just saying if this computer gets routed, we'll rely on the network. So we'll say that we're going to listen on any address. So there's a lovely in adder any. And we just have to listen on the same port. That's the only big change that we need to do there on the server side. So cool, that looks good. And then I'll make sure I close listen here. That looks to be good. I'm going to run this one just to make sure. I'm in x86. Shouldn't matter, but there we go. And my computer appropriately yelled at me for running it. So let me make sure it builds in x64 as well. Cool. So that at least ran. So now what we need to do is we need to bind bind essentially that networking data that we have to the socket. So when we do this, we're basically affiliating this block of text here that we set up as basically information for our listen socket, and we're going to attach that to the socket that we already created. That way, that socket will be our entry point to get and receive those packages. So binding is a pretty common step that you have to do on the server side, and it can get really, really complicated. You can bind lots of different things and different parameters to it, but at least in this case, we're just going to focus on the basics, and we're just going to look at binding sort of that core data to it. So let me jump back over here to my desktop. So to bind, I'm going to do it in a conditional statement, like I said before. We're going to bind, and it takes in a socket. So we'll give it listen, and then it's going to take in our server data. So it needs it though in sock adder form, and we have it set up as sock adder in. So we're going to need to actually cast. We haven't talked about casting. Casting is how you convert one type to another. We used it a little bit on that malloc. I mentioned it, but this is the first time that we're actually like using it. So we would add in struct sock adder star because it wants a pointer. So I'll group that over there. And then we would put in here the address of our server. And that's this server that we're listening on, that we're talking about here. And then we need to tell it in the bind the length of it. So that's going to be size of, if you remember that from our macro discussion a couple days ago, or for our malloc discussion, sorry, a couple days ago, size of server. So that just sort of tells it what it is. And then we say equals, there we go, if this equals a socket error, we're probably going to want to handle it. So I'll say binding listening socket failed. And then if this is good, we'll say and I'm very excited, as you can tell in all of these messages, they all get an exclamation point. So there we go. Cool. We now have our server bound. We just actually need to do something to it. So we need to listen for data coming in. So I'll put that there. So listen takes a couple of arguments. Takes a socket. So this is going to be listen. Might want to rename this then, if because listen is the command as well. Listen sock and reply sock. Ambiguity is not generally something you want when you write software. So let's not rely on the compiler to be perfect. So let's try this again. Now it found it. So this takes a socket, and then it takes a backlog, which I guess is how many connections we're going to go listen to. Don't quote me on that. I need to double check what backlog is, but I believe that's of like 3 connections deep. It can handle it once, but could be wrong. So there we go. And now we need to accept these new packets, or this new connection, and actually reply and do something with it. So to do that, we're going to need a loop. And remember I mentioned while loops. This is one of those good applications for a while loop because we want it to go for a long, long time. So we'll say while reply sock equals accept, and then this is going to be that cast again, sock adder star. In this case, we're going to call this one client. This is who's connecting to us. We want to fill that data, and then in this case, it's going to be size of there we go. Fill it full of that data. As long as we have a good, there we go. So what are we yelling at here? Doesn't like that. Oh, this guy wants the address. That makes a lot of sense. This is listen sock, not the listen command. And it doesn't seem to like that. So you know what we will do is we'll see if it likes it. Oh, no. Oh. Maybe it likes it there now? Nope. Oh, it wants it as an address. There we go. Pass it over as an address. You can see that when it, just for anyone watching, curious on how I caught that in the debugging, you'll see that it says argument type of int, which is why I gave it was an integer. It's incompatible with type integer star, so it wants a pointer to that integer. So we'll just give it a pointer to that integer. There we go. Cool. And that equals invalid socket. Beautiful. So what do we do in this while loop? So basically what this is saying is, while we can accept a connection, we should do something with it. So first off, let's print accepted a connection. Yay. And then we probably want to reply to it. So I'm just going to send a message in our send buffer. But I probably actually want to like receive some useful data from it too. Is so I'll say hello. It wants send buffer. Must be a modifiable value. Okay, well we'll have to do this as a string copy. So by statically declaring it, I need to do it as a string. So there we go. So string copy S. We always want to use the S one because it denotes a size and keeps things from getting basically in a bad state. So send buffer, and we need to give it a source. Hello. And I believe it will be good. There we go. And then let's send a message back. So we'll send on our reply socket our send buffer. And then we'll send just the data that we need to send. We won't set any flags. Now, string length, str length, looks at the buffer and finds the terminating string character. I know we haven't talked about strings. That could be probably a topic in and of itself. Let me know either in the messages or in the comments if that's something that folks are interested in. But string length just looks for the terminating character on the end of a string, then sends it. And then, yeah, that sounds pretty good. And we'll say if reply socket equals a invalid socket, print a cool. And the one other thing we should do is we should clean up here. There you go. Let me say clean up. Just to sort of clean up things before we exit. So there we go. So if we go to run this, and it's going to want network access, it's going to sit there and it's going to sit on listening for data until it has a client actually connect. So this is a pretty good sign, actually, the fact that we don't see anything on this. That means it's running. We just haven't, gotten it to connect to anything yet. So let's jump over to the client application and see if we can make it connect to our server. So I will jump on back over to that. We'll leave that running in the background. I'll add my WSA cleanup down here. There we go. Just to be complete. Okay, so if we're looking at this screen, you're like, okay, now we need to connect to something. I put in, my port and all that. Great. What are we going to send to this guy? Well, we can send some data to our server. So the first thing we're going to do is we're going to connect to it. So if our connect function of our sock, and then we have to do it's just like our bind or our accept. We have to do our casting again. Why is it architected this way? I'm sure you're probably asking yourself. I don't have a good answer. But if you know, feel free to leave a comment or a message for me. I'm curious. I've never, actually found out. So be really interested to find out. So we're basically saying that, if this connection here, it needs to do another comparison. So in this case, this comparison needs to be, I want to say, doesn't say what it returns. I'm guessing it also needs to be 0. But we'll find out together on that one. I don't remember off the top of my head, so sorry about that. We'll find out. We will printf. I'll put our classic. Something went wrong. Unable to connect. And put in my happy message there that we connected to the server, because that's really cool. And then we probably want to send and receive some data. So to send that data, I'll probably need that same string information I did in the running server. So I'll make sure I pull over that. So jump back over here to the client. There you go, include string.h. So if I want to connect to that server and send a message, rather than sending it on reply sock, we'll just be sending it on sock. Right? So I'll send our message. And send. There we go. I think this is another one where we'll find this out together if send does not, or I think it's if send equals 0 in this particular case, because it will tell us how many is sent. Find out. Sending failed. And we probably want to see what we got back from probably want to see what data we got back. And that can be done by using receive. So in this case, we can do if recv is receive on here. We might have a buffer coming back, so our reply buffer in this case. And then we need to give it a length. So this is going to be message size. There we go. And then flags that we want to set. We don't want to set any. If it equals, if we have some sort of error, this is sock, not socket. There we go. Receiving failed. Then we will printf received data. %s will print a string in these. There we go. So I can do reply buffer. Cool. So we can give this guy a shot and see if we get anything back. Oh, we had a build error. Which one don't you like? Ah, yeah, there is a different function. I guess it wants us to use now instead of innet adder. That's innet pton. Let's see that one. It's not showing me that. So instead, we're just going to turn off its warnings here, and I'll look that up here. And that should resolve that. No. There's an underscore out front I missed. No. And sock. Nope. Let me do a quick search then and catch this error. Okay, I did a quick search, just trying to fill in a hole in my knowledge. It seems it's inet pton. And so it's going to want this, comma, this is just straight from Stack Overflow, by the way, in case folks are curious, which is my go-to in case I need to figure out something. This is a curveball. There we go. And that is what actually, it doesn't want me to use the underscore T. Let me use that. If I need to find out where inet pton is. So I just pulled it up here. Let me pull this over on the Microsoft database, and this sort of tells me exactly what it's doing, which is great. It's the ANSI version of the function is. So basically tells me all the stuff I need to do, which is helpful. I just need to know where it's included. There you go, it's in WS2 TCP/IP, so I will need to make sure I include that. Up on top here. That's WS2 TCP/IP.h. There we go. That should resolve that, and I can delete all that. Let's see if that works. Cool. So I have a connection failed. 10047. So I'm going to search on that myself. An address incompatible with the requested protocol was used. If you receive this message, open a command prompt. So basically, it doesn't like my 127.0.0.1. So let's open up a command prompt and figure out what do I do? What do I have available? Well, I can do this 192, 168.1.32 should be fine. That's here on my home network, but make sure that works. That guy's still listening for data. Let's see if this one runs. So we're getting here that it does not like that particular, the 10047. Let's see if I can find it online here. So I'm curious. Just for sake of this, let's make sure that we're actually getting, that was one that I wasn't sure on, 1022. Maybe it did connect. So I do have it set up correctly. I went and I pulled up the page here. It says the return value. If no error occurs, connect return 0. Otherwise, it returns socket error in a specified error code. So that was right that we're not equal to 0. And that means we are getting a connection failed. We're just getting it failing on this particular see if I try removing that, although that's what the inner tube said would be the appropriate thing to put there. Yeah, this is the fun of something always going wrong, and this being live. But it's good because we'll figure this one out. Let's see here. I went too far. Just going to comment that out. Do I still have my... Maybe I need to put that before my includes. Let's see if I can get that to run. Okay, you're still listening for data. And you did connect. So that's good news. We did connect, but this guy didn't hear it. So now we're waiting to receive data back. So we'll stop both of these applications really quick. And let's figure out what's going wrong. I'll set this to be the 192.168 dot whatever address for my computer here, .1.32, just to be safe. Just so that we know that we're trying to connect to ourselves. There we go. If I pause this, where are we sitting at? So we're waiting to accept something. So that looks good. And then let's go to our client here. Let's see if we can send that data. Oh, cool. So we actually got our connection. And it just goes back and it received data hello and then a whole bunch of garbage. But there we go. So our client actually worked. I'm going to stop this and turn off the breakpoint. We'll go try that again just to be a little bit clearer. So if I go over to my client here and I go to run it, you'll see I got a whole bunch of garbage data. I did get the hello, but a whole bunch of garbage data. That worked exactly as we expected. That garbage data is from the rest of the empty buffer that was exchanged. So we just need to sort of narrow down that string so that it doesn't print all that extra stuff. So where are we at here? So here we go. It wants that reply buffer. And we need to add a null terminating character to the reply buffer. So that should be pretty easy. Basically what we're going to know is we're going to know how much data was received from this receiver. So I'll go and add another integer up here. Oh, I already have one, receive size. RECV. I already knew that was coming. So then I'll go apply buffer, and I'll look it up at the receive size. Access that array just like we did yesterday, and I will set that to be the null terminating character, which I believe is 0. I can confirm that really quick. There's so much knowledge that it's hard to keep it in hard to keep it all in your head, but yeah, it is 0. Cool. So if I go and I rerun that, it popped up here. And it received the data hello. Cool. Now what we probably want to do is make our server a little bit smarter. And I know that we're coming up here probably on the hour, so I'll close those windows. Let me go over to my server here, and I'm going to have my server, it sent hello, and then this guy over here also sent, we'll change that to be hello server. And we'll send this guy over here to be hello client. And we'll basically copy paste from that client code the exact same receiver code. There we go. I have a, it doesn't like me here, sock is undefined. Yes, we already defined it, so that's good. There we go. And then after we receive that data, just for sake of making this simple, we'll break out of the loop. So break is one of those keywords to exit the while loop. Cool. That looks pretty nifty. Just a little TCP server going back and forth. We should probably also wrap our send just like we wrapped our send in client. So we have our send equals 0 and all that. So I'm actually going to steal that part. We'll do. There we go. And wrap that, but we should be able to get this guy up and running now. So that person's listening for data. And this guy's going to run. And we have hello client on one and hello server on the other. So they exchange their information back and forth. So we now have a basic connection set up. There's no reason why we have to, stop here. You could have this thing go on and on and on forever and ever and ever. You can have this thing, and the two can exchange data until, forever. Or you can, set this up to stream data or whatever. It gives you lots of options. But this is doing a TCP connection. I didn't go into the details of why TCP over others, but this is a good way to sort of get you up and running doing socket programming. To switch this over to be a UDP, it's actually not that difficult. So let me save this. Lots of stuff here. I need to make this window bigger. Git add client CPP, and then there you go for everyone playing along at home. You can get the code from that. Cool. If we want to make this UDP, it's actually not that difficult. On the client side, UDP doesn't require this negotiation of a connection. So in TCP, think of it this way. TCP is like me saying, hi, how are you? And you replying, I'm doing fine. And I went, okay, here's some data. In UDP, I'm just like, here's some data. And you can choose to reply or not. So it actually becomes a lot easier. So if you want to do this in terms of UDP, I'm going to make a few highlights here. So you would obviously change your protocol to UDP. Not chance. And you can leave it as a stream. That's fine. And you create your socket. And then instead of having to call connect inside our client, so we have this connect. No need to call connect for UDP. So we can actually do this pretty easily. And I'm going to use a pound divine value of UDP to set this up for UDP and TCP. So if UDP is 1, we'll go there, and if not, so we'll say if equals 1. There are ways that you can do this with the preprocessor, but that's probably a little bit beyond this. We'll just keep it pretty simple here. So we'll set that to UDP. So there we go. That handles that one pretty easily. You can also set this up to use a datagram, which is my preferred. There you go. If you want to do UDP, but not required. That's fine. And then this, you don't need to connect. You have no reason to actually connect in UDP. And otherwise, you would just send data, and you would receive data, basically the same way. So there you go, and that would end that. And then on the server side, like I said, we'd have the same sort of thing. So cool, there's a new version of Slack available. I'll make sure I pull that down later. But we'll have the same UDP versus non-UDP stuff here in the beginning. So I'll pull this pound define over on the server side. So we don't have the concept of listening necessarily anymore in UDP because you're just receiving data. So you don't have to listen on a particular socket to open that connection. You can, but you don't have to. You can just send and receive data because there's no negotiated check. So to do that, if UDP equals 1, do stuff, else do different stuff. Oop. I'm going to use my dgram. Change that to UDP. There we go. we can still bind and listen for data. That's still a thing. We can do that. But you don't have to necessarily accept a connection anymore. You can just listen for data and reply back. But you can also listen to it as well and get the information back. So that's all in theory, if my mind serves me correctly, that we would need there. What message did we get? 10:45. Yeah, because you don't have to wait to receive data anymore. So this would be a big thing to wrap as well. For UDP, you can just receive data. So in this case, well, there we go. So for listening for UDP packet, basically you just need to receive on your listen sock. There we go. So that should run. Hopefully not error out. Nope, what were my build errors? Initialize local value. There we go. So there we go. That guy's listening for data. And if I go over to my client, and it probably sent data but didn't receive anything. Receiving failed. 1022 on that one. And that guy never got it. $122, not 1022. Did I not bind? That's our client. Try and keep these guys separate. Oh, I'm not worried about the receiving here. So, if we're not running UDP, we will try and receive data. That's fine. But our server is still waiting to receive a message. Let's make sure I didn't mess this up too badly. The fun of doing this live. So you're still listening for data, but you sent your data. I'm sure someone's yelling at the screen saying, "You messed this up." But this is sort of the joy of socket programming here. Let's see. I'm just doing a quick check here to see if I missed something. Oh, I lied. I do need a listen connection. That is the part that I messed up. So I do listen. I can also check listen though. Listen should not equal socket error. So we'll see. Listening on socket failed. Let's see if we can get. There we go. That helps. One zero zero 45. This is a fun one, trying to figure out what I messed up. Because I totally messed up something. So I'm curious here. This is the fun of debugging here and trying to figure out what I got wrong, because I don't get it perfect every time. I'm doing some quick searching to see if I missed something. Maybe it's I don't need the listen. It says it's not supported for this type of socket, so how about we group listen under that. Okay, that looks good. It's listening for data. That's okay. Now what happens if I go over here to my client and I run it? You're still listening for data, but your socket is closed. So let's look where our server is. So you have not yet received a packet from our listen socket. Because the receive size being that really, really negative number. Let's see if we can change that to 5 and see if that works. Maybe we're just waiting for that entire buffer to get full. You closed. You're still listening for data, though. We totally sent more than 5 things, so. Yeah, if I'm doing something wrong, definitely comment in the description below, and let's see if I can figure this out. Make sure I didn't make any ID10T errors here. Datagram. Listen socket created. We bind it. That looks good. So the receiver seems to be receiving that. Maybe it's something I did wrong here in the sender, that it's not appropriately sending. So here, on the client side, oh, I know what I did wrong. Because I don't know where I'm going, this should actually be send to. I have to give it some information on where I want it to send the information to. So let's go into the send buffer, and then because I don't have connect, I need to give it a destination, which is going to be struct sockadder star, and then cast it over to and server. Then I need to give it a I need to give it a length, I believe. And I think it wants the length. Does it want as a pointer, or is it? No. There we go. Let's see if that works. Got hello server that time, and my client sent. So there we go. The issue is on the client side. So yeah, so you have to use send to. So I will update this accordingly. There we go. I knew it was something small I was overlooking. I was just trying to figure out what. So yeah, send to, it needs to know what IP address. That makes a lot of sense of where it's going. So there we go. I feel a little better now knowing that it was something small and it wasn't, that sort of thing. But there we go. We have set up now a client and server that talks back and forth. It gives us the option to switch between UDP and TCP. I'll switch this over to UDP just to confirm that that side still works. But I sort of expect it to, because all we did was we wrap it. So get the server running. Now we'll get the client running. There we go. And I would expect the client to be done and socket closed. There we go. So client got its message, server got its message. So there we go. We got both of those up and running. I am going to comment this a whole bunch. You got to see me do some real-time debugging, which you didn't see in my other screen, just so I could sort of have it side by side. Was just hitting up Stack Overflow. I'll drop that in here as well. So in case you're ever curious on how to debug or go through some of these challenges, because there are so many details to writing software and it's impossible to keep it in your head the whole time, I hit up Stack Overflow. It's my go-to resource, and I highly recommend it as a place to go check out. So yeah, if you have a question like WinSock error 122 like we got before, so that evidently came up with no particular search results because I misspelled error. There you go. But it comes up with lots of different things. And this is why I was looking at in the other screen. I was just trying to go through these. I didn't want to take away the code in case you were following along. But yeah, that is the joy and challenge of writing software and trying to debug and figure out what little detail you missed. But yeah, hopefully you found this helpful. I'm going to keep going here. I'm going to flip the screen back over to just the code, and I'm going to go through it there, and I'm going to comment in everything, try and make it as clear as possible, and then I'll push this up to GitHub so that hopefully you can try playing with this little client and server as well. Thanks for sticking through. I know we ran about 15 minutes over today, so I appreciate you hanging in there with me, and we'll be back tomorrow, and we'll be talking about multi-threading, which is another much more complicated topic, so that'll be a lot of fun. So we'll catch you then. Thanks, everyone. I'll be coding here. I'll be hanging out watching the chat, too, in case there's anything that pops up. Otherwise, I'll catch you later.